Hello. In this segment, we're talking about how to approach identifying and scheduling the particular tasks that will be needed for your overall design process. In planning out an initial timeline, we can start by trying to think of as many tasks as we can that we know will need to be performed to the extent known at the time. We also want to think of how to break this down into as many subtasks, sub-subtasks, etc., as we're able to foresee at the time. As with all other aspects of the design process, which the planning and scheduling itself is part of, it too is iterative and subject to continual refinement or even drastic revision when warranted. And as with many parts of the design process, creating and updating the task list and schedule is ultimately an exercise of judgment that you'll gradually cultivate with experience. Now, at this point, I'm going to go over a fairly generic, abstract example that often works as a rough starting point for introductory design course projects. Of course, it would be both customized and further fleshed out for each project, but this often is a helpful initial template to work off of. So, starting out, as we discussed a while back, the front end work tends to revolve around defining our problem and setting up our requirements. Some common tasks that support these things often tend to include researching relevant background information, which can come from a range of sources, having discussions or interviews with various potential stakeholders, and fleshing out a list of your design requirements, which can involve using tools such as an objectives tree or functional analysis. Also, remember that we want quantitative or otherwise definite specifications where possible for our requirements, but only if we can truly support those decisions and it's not arbitrary. A key thing about this front-end work is that it tends to focus mainly on fleshing out an understanding of the what we need to do, rather than thinking about how we'll do it. Okay, the next, or middle realm of the process, tends to revolve around ideating and evaluating concepts based on your requirements. Some common tasks that can support this often include having brainstorming sessions to think of solutions that may achieve some or all of your requirements, creating morph charts to associate certain design requirements with certain aspects of potential solutions, and from that, generating overall design concept candidates. It also can include using an evaluation matrix to help you determine which candidate design concept should be selected to proceed on for further development, at least for the moment. Okay, then the later stages of the process tend to involve detailed design, prototyping, and testing. This can include refining the chosen design candidate to a point where your drawings and any other information about the design is sufficient to direct whatever prototype you're going for at this point, whether that's to be built by you or someone else. Note that this refinement aspect we're talking about here is where a lot of your requirements from earlier become a lot more specific. Sometimes people think of this solution-specific refinement of requirements as a reiteration of the main requirements phase. But other people prefer to think of this more separately because it's more about moving towards a solution rather than establishing the problem and the need. Either way, now that we're committing to a detailed design, at least for a given iteration, we'll need everything to be a specification in the sense of being objectively determinable, because remember, detailed design is about committing, at least temporarily, to decisions about what our current prototype is going to be. After detailed design, there's the actual implementation of the solution in whatever form that's going to take for your particular field and your state of development. This is basically where you create whatever prototype you're going for at this point. There are many ways to prototype depending on your iteration and various factors, but generally it should be something that helps you in evaluating how well a given solution idea would achieve at least some of your design requirements. So after that prototype is made, you need to do some evaluation with it. This means testing and inspection, and then analysis of those results. Then, based on that, try to reflect upon and identify what changes should be pursued in another full or partial iteration of your process. Now, in the context of a class, depending on the nature of the project and what sorts of setbacks a given team has encountered, there may not actually be time for many changes at this point. But it's still always a valuable exercise to think about at least what you would do differently. Of course, in real life, you'll also have later stage tasks that pertain to the long-term implementation of your product, such as the transition to manufacturing in the case of something to be mass-produced, or even planning for subsequent versions or anticipated redesigns or updates. Now, along the way through developing your product or process, you'll often have to provide various sorts of project deliverables. This can involve tasks relating to the preparation of oral presentations, written reports, and perhaps prototypes themselves that a client or supervisor may want to assess as milestones in your project. Okay, now of course, there's any number of alternative ways that what I just said could be organized, and many more specific subtasks and sub-subtasks would likely emerge based on the project particulars. Those examples were merely to give a general starting sense of it. Importantly, it is usually not possible to flesh out very much detail for the later stages, like detailed design, prototyping, and testing, until at least certain major decisions have been made on the front end. That is, having fairly settled requirements and some idea of the general concept chosen. Also, when starting out, you may have less visibility regarding where and how much you'll need to iterate. Realize that tasks will often run in parallel, whether within a given stage or sometimes even spanning different stages, particularly if you have concurrent iterations going on. In a team situation, this often means having different people focusing on different tasks. Also, note that in many larger organizations, particular engineers or even entire teams might focus on certain parts of the overall development cycle, such as requirements, conceptual design, detailed design, and testing, as well as whatever is going to be needed for the long-term implementation of a given product, such as manufacturing in the case of something to be mass-produced. Also, sometimes the development process spans multiple different organizations. For example, a university might develop something to a particular point and then collaborate with a company for subsequent development. Or a company might collaborate with a different company for the manufacturing of a product that it developed. There are many project management software packages that can aid with organizing and scheduling tasks for all sorts of projects. A common tool that such programs can generate and help to manage is known as a Gantt chart. This is a particular type of horizontal bar chart developed by engineer Henry Gantt, which shows the duration, sequence, and relationship, or dependencies, for all your tasks. Whatever tool is being used, it's best to try to think of these plans as living documents for as long as possible. Of course, at some point, budget limitations and milestone deadlines may force those to firm up. Now, let's briefly discuss some different general approaches to planning your development process. In certain fields, particularly software, for example, the nature of the discipline can lend itself to a highly adaptive project management approach known as agile development. The basic idea is that requirements, conceptual design, implementation, and evaluation are all as concurrent and integrated as possible for each iteration of each increment of progress, even if one aspect or another may be more prominent at any given point in time. There also tends to be higher crossover and fluidity of positions and roles on a team. Of course, like so many concepts we cover, you'll encounter various views on the details of Agile. Agile can be contrasted with what is sometimes called a waterfall model. This has more of a focus on trying to follow a sequential progression through the major phases, while still allowing some flexibility for iteration and customization as needed. Something closer to the waterfall approach is more likely to be needed in highly regulated fields, such as medical devices, partly due to the nature of documentation that's needed along the way. It's also more common in situations where prototyping may be rather difficult or expensive, meaning that we'd really want to maximize our prospect of success for any iteration. In any event, the waterfall process can be thought of as more traditional overall, although it exists in many forms with varying levels of definition and rigidity. So think of this whole dichotomy as more of a spectrum than as two distinct approaches. Even relatively structured or waterfall design projects should aim to utilize an approach known as concurrent engineering to the extent feasible. Concurrent engineering is basically about trying to integrate some aspects of the design process just to help shorten development cycles and/or reduce the need for reiteration. When concurrent engineering gets taken very far, it arguably approaches Agile. Otherwise, it could be thought of as a supplemental tool to help optimize a more conventional process. A common example of concurrent engineering is to try to incorporate manufacturability considerations into conceptual design ideation, rather than waiting until you have your prototype all refined and then throwing it over the fence, as they say, to the manufacturing folks. Concurrent engineering may also include having more chronologically parallel development of distinct elements of a system, such as hardware and software. And of course, depending on how concurrent engineering is implemented in any given project, it can have implications for which people are working together at which times, what resources are needed, etc. And of course, these all factor into project management overall. Okay. That's all for now. Thanks for watching.